These are examples from section 5.1 using the properties of exponents. Using the definition of exponents, what this problem says is that it wants to basically raise this base of 6 to the second 3 times. So we can write this as 6 squared times 6 squared times 6 squared. But if we write this out, it's just basically 6 times 6, 6 times 6, 6 times 6. If we count up all of these 6's, we notice that we could condense it to 6 to the 6. But again, we could actually use the powers of powers rules, and if we noticed, just the way that it's patterned, we can actually just take the 6 squared and just multiply it with the 3. And again, remember, the 3 doesn't have a base, and so that's why we can do this rule. So this just becomes 6 to the 6, which is the same thing as if you use the definition of exponents. So for this one, we could write out the numerator as this, 4 times 4 times 4 times 4. And the bottom, we could write it with a multiple of 3 4s. And we could reduce it one by one. So if we reduce this, what we have left over is basically 4 times 4, or 16. But again, because you are dividing the same bases, we can use actually the quotient of power rules. So again, if the bases are the same, we could take those exponents and take the top number minus the bottom number. So this does leave us with 4 squared, which equals to 16. Same as above if you actually just use the definition of exponents. So by definition, if you have a negative in the exponent, it's asking you to do the reciprocal base. If the number in the exponent is also another feature, so in this case you actually have to do 2 things. So the first thing is I'm going to tackle that negative sign in the exponent. So this negative sign is telling me to do the reciprocal of the base 7. So I come out with 1 over 7. Now again, at this point, I didn't do anything with the 4, but what this tells me is I can just take the base 1/7 and multiply it to itself 4 times. So that gives me 1 over 2,401. So with this one, in terms of the scientific notation, what we want to do is basically just multiply the things that we can. So in this case, because it's all multiplication, we can actually just take the 4 and the 7, multiply that together, and we can just go ahead and take 10 to the third, and multiply that with 10 to the negative 2, and put those together since those two have the same bases. So this becomes 28 times 10 to the, and remember in this case we want to take the exponents and add them because you are multiplying the bases. So this becomes 28 times 10 to the first, or 280. So according to this one, it's basically saying take x squared y to the negative 6 and multiply that to itself 7 times. But that's a little tedious. So if I notice the pattern here, this one here, we can actually use the power of power rules. So I'm just going to go ahead and take the 7 and basically multiply it to the exponent of each of the base that I see. So in this case, it'll be x squared times 7, and y squared, y minus 6, y to the negative 6 times 7. So this gives us x to the 14, y to the negative 42. And sometimes they will ask you guys not to leave it with negative exponents. So again, since this one here has a negative, that means we're going to do the reciprocal of the base y, which is 1 over y. But again, the 42 is telling you to multiply that to itself 42 times. So it's just y to the 42nd. So looking at it a little bit closer, again, we have x to the 14th. If we take, again, the reciprocal of this base here, because there's a negative with the y, we could write this as 1 over y. But again, this 42 is telling you to multiply that base, so in this case, this one right here, 42 times. So this is going to be 1 over y to the 42nd, because 1 to the 42nd is just 1. If we go ahead and put x over 1 and multiply straight across, then you will get this answer right here. For this one, it's pretty much the same thing. We want to multiply this entire base here 3 times to itself. But what we can do is just go ahead and distribute that 3 to every base that I actually see. So basically to the exponent of the base that I see. So just remember, in this case, the 2 does have a little 1 in the corner. So if we go ahead and do this, you get negative 2 to the first time, raise it to the third power. You have a squared, raise that to the third power, and you have b and raise that to the third power. Likewise on the bottom. And if you go ahead and simplify every single one, you get negative 8 times a to the 6th times b to the third times a to the 15th and b to the third. So you can go ahead and use the quotient of a power rule and just go ahead and take the top one minus the bottom one. And likewise with this one as well, take the top exponent minus the bottom exponent, because these 2 bases are the same and these 2 bases are the same. But again, if we just use the rules of exponents, what we can do, or powers, we can actually just go ahead and just cancel out things from the top and the bottom. So we know that a to the 6th goes into itself once. If we take out a to the 6th from the denominator, we get a to the 9th. B to the third divided by b to the third is just 1. So this one simply is just going to be negative 8 divided by a to the 9th.